Moving on to a second one of these, we're going to use the function f of x equals 2x to the third plus 3x squared minus 8x plus 3. So we're going to do the same thing. So we're going to come up with our p possibilities and our q possibilities. Remember, the p values are the factors of the constant. So it's really just plus or minus 1 and plus or minus 3. Nothing too extensive there. Then we'll zoom in. Then for the q values, it's the factors of your leading coefficients. So we got plus or minus 1 and plus or minus 2. So when we do our p's over q's, I always do the ones first. Like I'll do the 1 divided by 1, so give us plus or minus 1, and then the 3 divided by 1. So either way, you're going to get those just integers. Then we're going to do the numbers over 2. So we got 1 divided by 2, so plus or minus 1 half. And then the 3 divided by the other 2, so we have plus or minus 3 over 2. Now, again, you can use a calculator. In fact, the next problem is going to tell you straight up to use a calculator to figure out which ones are going to work well. But we're going to use the calculator on this one, and we find out that we end up with -3 as a good zero. So we're going to use -3, and we're going to use the coefficients from our original polynomial, 2, 3, -8, and +3 again. Going through the order, we drop the first number down. We're always multiplying by what's in the box, so we have 2 times -3 giving us -6. 3 plus -6 gives us -3. Multiply that by -3, we get +9. Add those two together, -8 plus +9, we get 1. Multiply that by the -3, we end up with -3. Add those together, we get 0, which is good. That's the whole purpose. So after we did that, if -3 is our 0, then x plus 3 is one of our factors, and we're left with 2x squared minus 3x plus 1. Now that's factorable. It's not the easiest, but it's not the worst that we could do. So 2x squared minus 3x plus 1 is factorable. We know it's going to have a 2x and an x because the first term in each group need to multiply to give us 2x squared. The other numbers need to multiply to 1. Well, thankfully, there's not a whole lot of options that multiply to 1, so it's either +1 or -1. Taking a look at our b value there, our b value is negative, so we're probably going to be dealing with two negatives. So let's try it out. We got -1 and -1. So if we were to double check this, 2x times -1 is -2x. -1 times x is -x, so that gives us a grand total of -3x. Now, from this, we need to find our zeros. So we have x equals -3. We already knew that one. That was the one we found by using synthetic division. 2x minus 1 equals 0. To solve for x, we're going to add 1 to both sides. And we end up with 2x equals 1. And then we divide both sides by 2. And we get x equals 1/2. For the last one, you can probably just eyeball it. You end up with just x equals 1. So we could have really started off with any of those. If you wanted to try 1/2, it'll work. I would strongly encourage you to start off by using the integers for your zeros. So if we had tried, say, +1, it would have worked, and we would have had to factor a different one. And after factoring, we would have gotten -3 and +1/2 as well. For the next one, there's a whole lot going on here. So again, this is one where you're definitely going to want to use the calculator to find a zero to start. So our p-values, our constant, let me zoom in, is -12, so you got plus or minus 1 and 12. I'll get to the 12 later. 2 is also a factor. So is 3. So is 4. So is 6. And so is 12. Yikes. Our q's are factors of our leading coefficient. Our leading coefficient is -10, so you got 1, 2, 5, and 10. So unfortunately, we have a lot of different p over q values. So we have p divided by q. We're going to do each of those divided by, we'll do each of the p values divided by each of the q values. Let's start with just the 1 to start. So we've got that plus or minus 1 divided by 1, which gives us, and I'm going to have to take up a good amount of space here, so I'm going to write this a little small, plus or minus 1. Then the 2, so we have plus or minus 2 divided by 1. Then the 3, then the 4, then the 6, and then the 12. Now we're going to do all those divided by 2. Well, plus or minus 1 divided by 2 gives us plus or minus 1/2. Plus or minus 2 divided by 2 is going to give us plus or minus 1. We already have that, so we don't need to do that again. Positive negative 3 divided by 2, we got plus or minus 3 over 2. Plus or minus 4 over 2, that's just 2. We already have that. Plus or minus 6 over 2, we already have that. That's 3. And then plus or minus 12 divided by 2, we already have that. That's the plus or minus 6 that we got. Okay, so now we got to do all of them divided by 5. So 1 divided by 5, we got plus or minus 1/5. Plus or minus 2/5. Sorry, my plus or minuses are getting messy. Plus or minus 2/5. What in the world? Sorry. Plus or minus 2/5. Then the plus or minus 3/5. Plus or minus 4/5. Plus or minus 6/5. And finally, plus or minus 12/5. Now we got to do all of them divided by 10. So we'll do the plus or minus 1 divided by 10. That gives us plus or minus 1/10. Plus or minus 2 divided by 10 is, well, plus or minus 1/5. Thankfully, we already got that. Plus or minus 3 divided by 10. That one we don't have. Plus or minus 3/10. 4 divided by 10 is 2/5. We already have that. 6 divided by 10 is 3/5. We already have that. 12 divided by 10 is 6/5. We already have that. Okay, that's a lot. There are, let's see, how many unique ones do we have here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. There are 16 different possibilities. So we could just go through and guess and check, or we can kind of do what I've been hinting at earlier, and well, what I've been straight up doing, to be honest, is just using a calculator to find one of them already, and then factor from there. So that's what we're going to do. We're going to use the technology, we're going to use a graphing calculator to find an x value that works. Now we're going to find an x value that works is x equals 2. So when we graph it, we end up finding that it crosses the x-axis, or it touches the x-axis at x equals 2. I believe it crosses. I'm not looking at the graph right now, but I'm pretty sure it does. So we're going to try to divide this out. And our coefficients that we had for the original function is -10, 15, 16, and -12. Always make sure that you don't have any missing terms. In this case, we don't, so nothing to worry about there. Going through our procedure, we drop the -10, multiply that by -2, we get positive 20. Sorry, multiply that by positive 2, we get -20. Add those together, we get -5. Multiply by positive 2, we get -10. Add those together, we get positive 6. Multiply that by 2, we get 12. Add those together, we get 0, which is good because that's our remainder. So now x equals 2, the factor equivalent is x minus 2. And now we're left with -10x squared minus 5x plus 6. Now I'm looking at that and I gotta be honest, that doesn't look like it's the most or the easiest thing that we could ever factor. So we're gonna take this and we're gonna use the good old quadratic formula. So quadratic formula, remember, is my goodness, I'm tired. X equals -b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. So we have x equals -b. Well, b is -5, so we got -5. We'll clean that up in a second. Plus or minus the square root of -5 squared minus 4 times -10 times 6 all over 2 times -10. Cleaning it up, we got x equals 5 plus or minus the square root of -5 squared. Sorry, I'm off the page. -5 squared is, let's go with this. -5 squared is 25 minus 4 times -10 times 6. Well, 4 times -10 is -40. -40 times 6 is -240. So it's minus -240, or in other words, plus 240. All over 2 times -10, which is -20. We can clean this up just a little bit more. We got x equals 5 plus or minus the square root of 25 plus 240 is 265. All that being divided by the -20. Folks, there's not a whole lot we can do with that. That's a perfectly acceptable answer. So we're going to say our zeros. We found one using the graphing calculator. So we have x equals 2. The other zeros would be x equals 5 plus the square root of 265 over -20. And the third one would be x equals 5 minus the square root of 265 over -20. Those zeros aren't the prettiest zeros you'll ever see. but that's okay. Sometimes real life, you're not always going to get pretty answers. So those are 3 zeros.